All right, so it is 10 a.m. and we will get started with our first actual lecture of Gen Chem 1. So I'm going to pop up the PowerPoint. Feel free to either watch my screen to follow along, or if you have your own printout or a second screen that you can watch, that works too. So let me get that up. All right, minimize this. All right, so check out the chat. How do we turn in homework? Okay, let me answer that before we get started. So there's a couple different types of homework. There's the quizzes. The quizzes are found in the dated folders where you'll see like quiz 1, quiz 2, quiz 3. There's a reading guide, turn it in, where you will see turn it in link in the dated folders where you can turn in your reading guides. And the actual homework, which I'll post after today, that will be found under tools, mastering assignments. And I'll make an announcement about that today since it's our first time we'll do homework. And as a reminder, make sure you do your reading guides in your quizzes before 10 a.m. Monday, Wednesday, Friday, because I was just browsing at like 9:55 a.m. and about a third of you haven't done it yet. So yes, if you don't turn it in by 10 a.m., it is considered late. For the first one on this Monday, I will probably let it be okay unless you're like a half a day late. But moving forward, I don't really accept late work since it's all laid out there. It can be PDF, it can be pictures, it can be any format that you want. For the reading guide, I wasn't able to turn in all my pictures at the same time. Yeah, so if you have, there's one way, there's a couple ways you can do that. If you can get it all into one picture, if you can like print out multiple pages and like zoom out and take a picture of that, I could use that and you could turn it in. If you do have to take multiple pictures, I guess you can email it to me. I'm gonna say try emailing it to me as your last resort, because if I get a bunch of emails, it just makes all these reading guides be in different places, and it's easy for me to accidentally overlook that if you turned it in. So try to do the turn in links just to make my life easier. Zip file is okay to turn in the homework. I don't know if turn it in allows zip files. I would try it where you take all your that's actually a good idea. Take all your photos, highlight them all together, right click, and try to zip it, and try to put that zip folder into turn it in. If so, I might be able to see that. All right, but other than that, if you still have questions, feel free to type them in as we go along. Other than that, I will get started with our lecture. Multiple submissions might not work. I will check that. I have not checked to see what the turn it in looks like for everybody. Generally, you can only do one submission with turn it in. I think if you keep resubmitting, it will just overwrite itself. So if you did multiple submissions, I might only get the last page. And if that's the case, I will email you and just say, hey, I only got one page. Could you send me the rest, please? All right. I think there was one more chat. Okay. All right. So let's begin. And the subject that we are studying in this class is chemistry. And chemistry is really the science of trying to understand how matter behaves and how we can interact with this world, how this world works by looking at the small parts that make up matter. looking at atoms, and those atoms make up molecules. And basically, everything you can see around yourself is made up of atoms. So my desk, this computer in front of me, the pen I'm holding, the air that I'm breathing, are all made up of atoms. And atoms are so small, we can't see them even with a very good microscope. They're so tiny, but they build everything. And if these atoms are connected together, depending on how they're connected, both what atoms are connected and how they're connected, we get molecules. So on the bottom left here, we have water, which is 1 oxygen, 2 hydrogens. Next to that is basically the same molecule, except we add 1 more oxygen. And when we do that, we get hydrogen peroxide. So just by changing 1 molecule, we get something that we can drink to something that would kill us if we drank it. And then on the right here, we can see a more complicated molecule. And this is actually from my field of expertise. I'm a biochemist by training. And what this is called a heme. A heme's in all your red blood cells, and it will be carrying the oxygen for you in your blood. Now, I'm not going to ask you to memorize heme. I'm never going to show you heme on a test and say, what is this molecule? I just want you to get the scope of how these molecules can be, for lack of a better term, very varied. They can be quite complex like heme or simple like water. Now, since we are talking about science, this is a science class, we have to talk about the scientific approach. How do scientists come up with the things they say? And I think this slide is actually very valuable in today's culture, where it seems like almost half the people in America don't believe what a scientist says, which is like super sad. But the way scientists make up, well, there's a poor choice of words. The way a scientist actually present their data is very rigorous. We do a lot of tests. And so we're just going to go over the keywords in the basic scientific approach. And so I'm going to try to get a pen going on here. Perfect. All right. So we start with our observations. A scientist will see something in the world, or they'll make measurements in the world. And from those measurements, we can go 2 ways. One, we can make a hypothesis. And a hypothesis is just our first stab at saying, okay, I saw this observation. I think this observation is happening because of this reason. That's a hypothesis. And a hypothesis has to be falsifiable. I have to prove it wrong. For example, if I have the hypothesis, the reason why humans go to sleep is because magical fairies come and sprinkle dust in their eyes, but we can never see these fairies and we can never detect them. That is not a valid hypothesis. I can never prove that wrong. Aliens are controlling all my thoughts. Okay, I can't really prove that wrong, so that's not really a great hypothesis. So that's a hypothesis. Has to be falsifiable, and it is our basic understanding of what's happening. Rarely, though, we can go, there you go. We can go on this other path in which our observations become a law. Now, a law is incredibly rare to make, and basically a law is this observation is always true. The law of the conservation of mass. All of the mass in the universe will never change. It's there. It's a constant. The only thing we can do with mass is change it into energy, or energy into mass. The amount of stuff we have in the universe will never change. So that's a hypothesis, and that's a law. Now, after we do some tests, so we're going to take our hypothesis and do some experiments on that. And with our experiments, depending on what our results are, we'll go back and modify our hypothesis. And we'll do this over and over and over and over again. And it is possible to go from a hypothesis to a law, but again, super rare. It is rare anybody makes a law nowadays. But we do more and more experiments, we make our hypothesis better, and eventually we'll make what's called a theory. Now, this is a term that people who haven't taken science classes don't really understand all that well, the term of theory. For example, the theory of evolution. One of the things people say about the theory of evolution is, it's just a theory. You can't, that's that in science talk, that means people don't really think about it all that much. Not true. A theory has gone through a lot of testing, a lot of data. When people say it's just a theory, what they actually mean is it's just a hypothesis. When people think of the word theory, I think they mean hypothesis when they say something like that. Just to give you an idea of the theories we have out there in the world. The theory of gravity. Gravity is not a law. When I drop my pen and it falls to the earth, that's actually a theory. It's not a law. The earth goes around the sun. That's a theory. And I guess there's people out there on the internet now who says that doesn't happen. But yeah, the earth going around the sun, that's a theory. Everything's made out of atoms. That's a theory. We get sick from bacteria and viruses. That's a theory. Like everything in science is basically a theory nowadays. So don't get confused from theory. Now we can take that theory and we can continue to revise through experiments, so on and so forth, and make our theory better, better, better. All right. So let me clear those annotations. Get out of pen mode. All right. So that's the scientific approach. Now I have a question. And here I'm going to do a poll. I've never tried this before, so let's try it. I have a bunch of statements, and I want you to try and see if it's an observation, a law, or a theory. Now, in this poll, it should be anonymous, but I want you to try and answer all these, what you think. Are we looking at observation? Are we looking at a law, or are we looking at a theory? So go through those and try to answer those right now through the poll, which hopefully just popped up on your screen. And as always, if you have questions about this, feel free to put it in chat. And you should be able to just message me privately if you don't want everybody to see your question. We'll probably do a minute or so more here. Looks like 64% of you have submitted. So give you about a minute to think about this. I'm going to say about 20 more seconds. All right, let's take a look at this. So all matter is made out of tiny, indestructible, I'll share results so everybody can see those. All matter is made out of tiny, indestructible particles called atoms. Yes, that is a theory. So atomic theory. It's one of these things that's really kind of hard for me to explain. What's the difference between a theory and a law? So basically, a law means I looked at everything that is matter and I checked to see if it's made out of atoms. If that's true, then atomic theory would become the atomic law. But here, it is possible, although super unlikely, but it is possible something out there is not made out of atoms. So right now, atomic theory is a theory. So that's theory. When iron rusts in a closed container, the mass of the container and its contents does not change. That's an observation. You can do that experiment and you see it's true. So that's an observation. In a chemical reaction, matter is neither created nor destroyed. So this one's actually a law. And this is why it's hard. And this is why we really don't make laws anymore. So this law was created about 200 years ago. And what the scientists saw back then is no matter what experiment they did, matter would never change. The only thing we can do with matter is convert it to energy, and Einstein gave us that equation, E equals mc squared. It's how we convert energy to matter. But the law of conservation of mass says we cannot create or destroy matter. So it's a little tricky there between theory and law. When a match burns, heat is released. Yeah, I light a match, I put my hand over it, it's hot. That's an observation. Chlorine is a highly reactive gas. I can observe that, yes. So when I do reactions, that's an observation. If an elements are listed in order of increasing mass of their atoms, their chemical reactivities follow a repeating pattern. That is a theory. That is periodic theory. That's where the periodic table comes from. I can understand why you would put both that as an observation in the law, because you could say, you know what, if we line these up, I observe that happens. That is true, but it's kind of gone past the point of just observation, where we put a lot of different elements into a periodic table and we see, oh yeah, that theory holds up. And what we can build on that, that's the big thing about a theory. Once we have that in place, we can put new knowledge into that theory. So the idea is, if we discover new elements, their reactivities should follow a pattern based on where they fit in the periodic table. So that's the big thing about a theory, is that we can use our theory plus new information and plug that new information into our theory. Law, again, since there's elements not quite discovered yet, we can't make that a law, and that will probably never become a law. Scientists nowadays don't really make, like I said, repeating myself, it's hard to make a law nowadays. But I hope you saw through this exercise, you got a better idea of theory, observation, and law, and you also learned how fluid these things can be. What's the cutoff between a theory, law, and observation? It's really how much experimentation you've done, where you could say something now becomes a theory, something's a law, something's an observation, something's a hypothesis. It really just goes with the amount of experiments and knowledge you have on that. But good, looks like that poll worked. All right, so let's go on to our next slide. We have a question here. I thought chlorine was a theory because of its location on the periodic table. So That would go with periodic theory. So you could make the argument that yes, chlorine is going to be reactive based on periodic theory. I guess I was thinking along the lines of um, I react chlorine in a reaction, or I put chlorine with another element and I see chlorine reacts a lot. So I observed that. That's the way I thought about the question. But if you wanted to answer based on periodic theory, where chlorine is on the periodic table, it is a theory that chlorine would be super reactive. And I would buy that. I'm okay with that line of thinking as well. So you can see it's very fluid even from the way I approach these questions as well. If you get this question on a test, I will make sure that those types of distinctions I will make super clear to you. So there will be little to no gray room if I ask a question like this. And keep in mind, just as a repeat, these types of questions are going to be similar to questions you might see on your test. All right. So in chemistry, we have three basic types of matter, or three phases: solid, liquid, and gas. There are more. We're not going to cover those in Gen Chem. You get to talk about those in higher levels of chemistry and physics. But what I want everyone to do, you do not have to share this with me. Think of a definition that includes volume, shape, and movement of atoms for solid, liquid, or gas. Again, don't need to share. I just want you to take a minute and refresh yourself on, if I was going to describe a solid, liquid, and gas to a chemist, and those definitions include volume, shape, and how the atoms move, how would I do that? So everybody take a minute and think about this now, how you would answer this. I guess I really need to get some thinking music while I ask questions like these, so everyone's not just drowning in silence. I'll do that maybe next time. We'll do about 30, 35 more seconds. Okay, chats. Yeah, again, so no need to share with me. These are mostly just kept to yourself. So I will now go through these. So let's start with a solid. So volume. Solid has a fixed volume. A brick. Let's say I have a brick in this glass jar, right? So I'm trying to put the brick into this jar. The brick is not going to take the shape of the jar. The brick is going to smash through the jar because the volume, or the volume of the solid does not change, or does the shape. So as a fixed volume and shape. my brick is not going to like squeeze to fit into that bottle and then like go back into being a brick. So fixed shape, fixed volume, and little movement. So you might be surprised to hear this. Maybe not, depending on how much chemistry you know. Solids are moving. Everything in the universe is always moving. The only time an atom will not move is what we call absolute zero. So at absolute zero, you stop moving if you're an atom. And absolute zero right now is impossible to get to. We can never cool something off so much we get to absolute zero. But every atom in a solid is vibrating. So all the atoms around you, the chair you're sitting in, the computer you're looking at, the desk your computer may or may not be on, your skin's made of atoms. Every atom is vibrating. So solids have very, very, very small movements. Okay, so no, you're not supposed to turn in the PowerPoint questions. PowerPoint questions are what we do in class. The homework will be on mastering chemistry. What you're supposed to turn in are the reading guide. That's the only thing you need to turn in and do the quiz. All right. So that's our solid. Our liquid. Liquids also have fixed volume. So take a glass of water. Try to compress that glass of water. That water is not going to compress. If anything, it'll just move away from your hand. So we cannot change the volume of a liquid that easily. It will change a little based on temperature, as will everything. But if we are at the same temperature, liquids do not have a fixed volume. But they will adopt the shape of their container. Right? So if I pour water into this glass beaker, it's not going to shatter the beaker. It will go right in. So they have a fixed volume, but they will adopt the shape of whatever they're in. And they have a lot more movement than solid. So basically in this liquid, atoms can move in any direction in the liquid. They can't really move out of the liquid that easily. They can, but that's for, we're going to learn about that later on. I think we learned about that in Gen Chem too. So there's movement inside the liquid, but they are restrained to the liquid. While in a solid, they can't move around. They can just vibrate. So pressure. If I try to compress a liquid, you need a lot of force. You're talking about thousands and thousands and thousands of PSI, and then you're going to turn it into a solid. Liquids are very, very slightly compressible. Not a lot. Not like anything significant, but they are barely compressible. But in generally not really. They're already packed in as much as they can. When you're looking at a glass of water, that is just full of atoms. There's no really empty space in that water. It's just full of water atoms. So that's why you can't really compress it. The answer for the quiz was none. I do not know the quiz off the top of my head, but you should be able, I'll make the answers available when I go and grade them so you can know what the correct answers were. All right, gas. So a gas, no fixed volume. So if I put gas in this container, it's going to take the volume of that container. If I let a gas out of the container, it's going to take the volume of the room. So the gas takes the volume of whatever container it's in. And it also adopts shape of whatever it's in. So it will adopt the shape of that beaker. It will adopt the shape of a room. So movable, flexible volume. Volume can shrink and change, no problem. Shape can shrink and change, no problem. And 360 degrees of movement. They can move any direction, up, down, left, right, straight forward, vertically, horizontally. They can spin. They have the most movement of everything. So that's our working definitions of a solid, liquid, and a gas. Right, so I will clear these drawings and move on to the next slide now. Yeah. So now that we learned about the three basic types of matter, solid, liquid, and gas, let's talk about how we classify them. So we're going to start over here. Let me get my pen out after I just took it up. So first, we have two distinctions. Are we dealing with a pure substance? Are we dealing with a mixture? So a pure substance just means it's made out of one thing, like all oxygen, all water, stuff like that. So we're going to start with the pure substance. Can I break this pure substance down? That is, does your substance have any bonds? So if there's no bonds, that's an element. Helium, that's what's being shown here in the Goodyear blimp with helium. Helium's an element. It doesn't have bonds. I can't really break it down further. Now, yes, I can break it down into protons, neutrons, and electrons. We're not going to get to that yet. We're talking about just elements are our smallest thing for right now. While compound does have bonds. So H2O is made out of one oxygen, two hydrogens. So I could break these bonds and I would get two hydrogen atoms and one oxygen atom out of it. So I can break down a compound into simpler elements. That's the difference between an element and a compound. Now, mixture is made out of multiple compounds. That's generally how it is, or multiple elements. You can have a mixture of elements, or you can have a mixture of compounds, or you can have a mixture of elements plus compounds. That's what a mixture is. And we have two types, heterogeneous and homogeneous. And since this is the first time we've seen these words, let me explain what hetero and homo mean. Because if you continue with science, you're going to see these a lot. Hetero means different. Homo means the same. So a heterogeneous mixture means it's made out of different layers. The layers are separated. That's why we're seeing a wet beach here. You have one layer that's water, and you have another layer that's sand. And clearly, these two layers are separated from each other. So that's why they are different. That's why we call this a heterogeneous mixture. Now, let's take tea with sugar. Here, the sugar and the tea are uniformly distributed in our tea. So no matter where I take a sample of tea from, so let's say I take like a little tool and I get tea from the very top, or I get tea from the middle, or I get tea from the very bottom. No matter where I get my sample of tea from, it will always have the same ratio of sugar to water. That's what a homogeneous mixture means. It is mixed 100% evenly. While heterogeneous mixture means it is not mixed uniformly. If I take a sample from the top of my beach, I will get all water. If I take a sample from the bottom of my beach, I will get all sand. So that's what makes them heterogeneous. So those are our four different types of classifications of matter. And it's one thing to hear me talk about that. It's another thing to test yourself on that. So we're going to do another poll here. Question 3. And I want you on this poll to tell me what you're looking at. Are you looking at an element, a compound, a homogeneous mixture, or heterogeneous mixture? So let's have that poll running right now. And by the way, I will be posting the answer to these questions, just as a reminder, once we're done with all the questions. Yes, videos. I am recording this, so these videos will be posted. Case sometimes I talk fast too. I know that. I am not from Texas originally, and I think Texans may speak a little slower than where I'm from. So I've been told sometimes I talk a little too fast, especially when you're talking about something like chemistry, which is a foreign language. Okay, we got about 80% in. Let's do like another 30-ish, 40-ish seconds. So there's an app called FreeCam that lets you screen record. There's also, if you have PowerPoint, inside PowerPoint, you can also screen record. And that just comes free with PowerPoint. That's how I make the videos I posted online. I forget exactly how to go there, but yeah, it will record the screen for you. I don't know. Yeah, it should record the sound as well. But yep, some options out there. All right. So box A, that is a compound. And the way you know it's a compound is that you see these different elements. You see carbon, which is black, connected to oxygen, which is red. And they're connected, so that's a compound. And you're looking at carbon dioxide, 2 oxygens, 1 carbon. B, so looks like there was some thought whether homogeneous mixture is the correct answer, but it looks like there were some, about a quarter of you for compound and a quarter for heterogeneous mixture. All right, so it's not a compound because there's different types of elements in this. So let me get my pen back out. So you have water right here, and you also have this molecule, which is ethanol. Don't expect you to know that, but that is ethanol. So what we're looking at here is alcohol. Ethanol plus water is alcohol. And this is homogeneous because it's pretty well mixed in. Now, this is a small box, so it's kind of hard to see, but let's compare that with C. Here we have, in C, we have water, and here we have 1, 2, 3, 4. Looks like hexane. So here we have oil and water, and I'll get to those questions in a sec. Here we have oil and water, and they are separated distinctly. We have these different layers, which makes this a heterogeneous mixture. Is A H2O? No, A is carbon dioxide, yep, as was stated. To be H2O, that middle atom needed to be white. Okay. D, we have hydrogen. That correct is an element. So remember, if there's only one thing, so A and D are good examples of that. We only have one thing in the box. If it's only a one thing, it can't be a mixture. So we have to ask ourselves, do we have bonds or not? D, we don't, because there's only one atom. They're all separated. So that's an element. And A, you can see we have atoms that are bonded together. And so that is a compound. All right, very good. Let's get to that question. So if they are distinctly separated, it would always be heterogeneous. Yes, so that is the definition of heterogeneous. They are in distinct layers. Your best example that is probably most familiar to everybody, and the one I'm actually showing in C, is oil and water. You mix oil and water together, you get different layers. So it's still a mixture, but depending on where you take your sample from, you'll either get a sample that's all oil, all water, or a mixture of oil and water. Compare that with your favorite alcoholic drink. No matter where you take a sample from, it's going to be the same amount of ethanol to water. If it's halfway mixed, it would be heterogeneous. Homogeneous is fully mixed. So let's say that you're trying to add sugar to water and you don't dissolve the sugar all the way. So some is dissolved, some is not. You still have layers. You have a layer of sugar water and a layer of sugar. So that is still a heterogeneous mixture. Homogeneous is I am completely mixed 100% of the way. Good questions. Okay. Let me get that. Let me get out of the pen mode. Okay. Let me get out chat. All right. So the last thing we're going to talk about here in the last 8 minutes are physical properties versus chemical properties. So we talked about atoms briefly. We talked about the types of matter we can have. Now let's talk about the different properties of these matters. We have two types of properties, physical property or a chemical property. And a physical property is something that substance has that doesn't change its composition. That is, it does not change the way the atoms are bonded. That's what I mean by changing its compositions. Bonds don't change. So gasoline or smell in general. When you smell something, you don't change the bonds of that substance you're smelling. So a physical property is smell. Taste. If I taste something, I don't change the bonds. Color, appearance, melting point, boiling point, density. All of these properties of a substance, I don't change the bonds to measure them or look at them. So they're physical properties. While a chemical property, lighting something on fire, how flammable is my substance? Well, when you light something on fire, you are changing bonds. That's what you do when you light something on fire. So that's a chemical property. When you are corrosiveness or acidity, when you are melting, or not melting, but when you put an acid onto a metal and that metal is being eaten away, what's actually happening is that acid is changing its own structure, changing its own bonds to destroy that metal. That's what's happening on the atomic scope. Toxicity. When something's toxic, a lot of the times what happens is that if you eat it, your body will process it. And when it processes it, it will change the bonds, and whatever it makes will accidentally kill you. So that's just a shorthand. Physical property. When I look at this, am I changing bonds or are bonds changing? No, then it's the physical property. Am I changing bonds? Yes, it's a chemical property. So to make sure we have a handle on that, our last questions for the day And our last poll of the day. So let me get this new poll out. Launch poll. All right. So for box A, B, and C, ask yourself, am I looking at a physical change or am I looking at a chemical change? Do, 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 do. Do, 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 boop. I cannot sing. Do, 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 do. Do about 30-ish more seconds on this one. Are we looking at a physical change or a chemical change? I know I said 30 seconds, but we'll do like 15 more. Then I'll share the results. All right. So A, that is a physical change. What we're looking at A is basically melting. And what you can see is that no bonds are being broken. It's just that our molecules are being separated. The gap is becoming larger. So this would be an example of like melting point. Our molecules are becoming further and further apart. While in B, we are changing bonds here. So here we have oxygen, so that's O2. Here we have methane, CH4. And what we're making is water plus carbon dioxide. Basically, when you burn anything, you always make water and carbon dioxide. And that's what we're showing here in the burning of methane. We are making carbon dioxide and water. This is flammability. Methane is super flammable, and that property is a chemical one. C, basically the same thing as A. This is water. It's ice. So we're going from ice to liquid. Or it could be, actually, sorry, I'm wrong. I just realized I'm wrong. Liquid, this is gas. I can tell it's gas because the molecules are really far away. So here is a boiling point. So that is a physical property. We're not breaking any internal bonds. We're just changing the type of matter, going from a liquid to a gas. All right, clear. And that, ladies and gentlemen, is our time for today. And we're exactly right on time, 10:50. Perfect. Well, I hope you enjoyed our first day of lecture. If you have questions about anything we went over, or if you still aren't sure about the quizzes, the reading guides, please shoot me an email. I'll be posting this right now. Is there mastering chemistry due this week? Yes, I will make the assignment probably within the hour. That'll be due on Sunday, and I'll make an announcement probably like later this week, just to remind everyone about that. Otherwise, everybody have a good Monday. Hopefully, I will see you on Wednesday. Take care, everybody.